Hello everyone and welcome to .NET Core Central. From my last few videos, I have been talking about how to build AI agents using C# and .NET. Mainly, what is the concept of an agent, how to build AI agent using the Semantic Kernel framework. And in my last video, I talked about another important component or another important concept in the AI world, which is Model Context Protocol. And Model Context Protocol architecturally is broken into three main components: a Model Context Protocol server, a Model Context Protocol host, and Model Context Protocol client. Now, if you remember, this is the diagram which we went through in my last video, where we talked about the three major components of Model Context Protocol: the Model Context Protocol server, and then the Model Context Protocol host, which will host multiple Model Context Protocol client, and each client talks to its own dedicated server. In my last video, I have built a Model Context Protocol server, and then I have used Visual Studio Code to call the Model Context Protocol server through the AI agent in Visual Studio Code, or the GitHub Copilot AI agent. Today, I'm going to show how we can use a semantic kernel application as a Model Context Protocol host, and then in the semantic kernel application, we are going to create an instance of Model Context Protocol client, which will connect to the MCP server, and then we are going to test the output. This was the Model Context Protocol server we built last time. It mainly had one tool which exposes weather, and I have hard-coded weather information for 3 places, and it just returns the weather. And then a couple of videos back, I built this chat agent which uses semantic kernel to build a chat application. And here also I had a plugin for semantic kernel, which is nothing but tool. And the tool was an in-memory tool which was doing the same feature. It was essentially a tool for weather agent. So what I'm going to do today, instead of using the in process tool, I am going to use the MCP server for achieving the same functionality. So for the MCP server, I have to first install the MCP NuGet package in this solution, and then use the MCP client to connect to that MCP server. So here I already installed the Model Context Protocol NuGet package, and this package is still in preview. So I selected the pre-release and I'm installing the 0.4.0 preview 3. That's the installation. So once we go here, I'm going to keep this code as is, and if you want to understand what this code is, you can look into my video. I'm going to provide the link for both the chat agent video as well as the Model Context Protocol server video so that you can refer them if you have not seen them yet. But this one was just in a loop asking user a question, and based on the user question, it was using the OpenAI chat using the GPT-4o mini model, and then using the chat completion, passing the tool and semantic kernel, just figuring out what is the answer. And the AI was, or the semantic kernel framework was providing the tool based on the AI output, executing the tool, and then using AI providing the appropriate response. So here, to use the Model Context Protocol client, what I'm going to do first, I'm going to create the client. And for creating client, first I'm going to use the client transport or HTTP client transport, because in my MCP server video, the MCP server that I created, it is a HTTP streamable MCP server. So here I'm going to use var client transport is equal to new HTTP HTTP client transport. That's the one I'm going to use. And here I'm going to use the HTTP client transport options. And for the option, the only thing we have to pass is the URL of the MCP server. So for that, first let me run the MCP server, and I have put a breakpoint in the MCP server to show that the call is coming to the MCP server. So the MCP server is running at localhost port 5165. Now I'm going to go here and to the endpoint. Endpoint is based on URI. So I can pass this URI. And the next what I'll do is I'll create the client, and this is going to be await MCP client dot, and I'm going to use the create async and then pass the client transport. And this is going to create an instance of MCP client. Next, what I'll do is I'll extract the tools out of the MCP client. So I can do var tools is equal to wait client dot list tools async. So that's the method we are going to call. This is going to list all the tools. And I'll just loop through the tool and print out the tool information for the time being. So I can do console dot write line, and here I can do tool dot name, comma, tool dot description. That's all I'm going to do for the time being. So this should print out only one tool. And what I'm going to do is I'm going to stop it for a second. I'm going to make it as get weather MCP, just so that it is clear that this is based on the MCP server, because the other one is not based on MCP server. So the server is started again. And if I go here, this weather plugin name is just get underscore weather. So now I will run this one. I put a breakpoint here because I don't want to execute through the entire code. I just want to show you that we are able to create a client transport, then create MCP client, list the tool, and able to print out the name and the description of the tools that are available in that MCP server. So if I run here, you can see I have the breakpoint is it, and now you can see that get weather MCP. That's the name of the tool which we defined in the MCP server and the description of that. So this is working as expected. Next, what we want to do is we don't want to use this plugin from in memory. That's not our goal. So I'm going to comment this out. But instead, what we are going to do is we're going to use kernel dot plugin. We still have to add a plugin, but instead of adding from type, we are going to say add from function. So we're going to provide a function which will have a name and a kernel function. So here we are going to give the name as weather. And for the functions, it's an array. If you remember, it's an IEnumerable of kernel functions. So we can extract that from the tools, from this tools list. And how we are going to do that? We can do tools.select, and we can say tool dot, and there's an extension method called as kernel function. This extension method as kernel function, what it does, it converts an AI function from the Microsoft.extension.ai namespace to a kernel function if it is not already one. So we are going to, because, so here T is an MCP tool. So it's going to convert this MCP tool as a kernel function. Now, one thing to keep in mind is, as I showed, this is still in pre-release. So this one, as you can see, it is throwing an error saying that this is for evaluation purpose only and subject to change. So it will change when it will change. For the time being, what we are going to do is we are going to just ignore or suppress in source. So now this is going to suppress this and we should be good. So now I'm going to, everything else remains same. So if I walk through, initially we are adding the Azure OpenAI chat completion, and then here we are using the kernel, which is builder.build, because we use the kernel dot create builder, and kernel is nothing but from semantic kernel. And then we built it, then we got the just completion service out of it, which is added by this particular method. And then we were using the auto functional behavior, meaning the function call is going to be automatic. We were providing a history, chat history, and then we were adding the user message to a chat history, whatever the user writes into the console, and then passing it to the get chat message content async method. We were passing the history, then the execution setting, which is telling it to run or execute function automatically, and then the semantic kernel. And then after that, whatever result comes out, we were just printing out the result. And then we were adding back into history what was the last message, so that the AI has a memory of what has happened. So everything is going to remain same. The only thing we're changing is, instead of using a plugin or tool from in-memory, we are trying to add a plugin from tools of an MCP server. And here, this MCP client is dedicated to this client transport, which is dedicated to the MCP server running here. So now I'm going to run this, and I have a breakpoint at the MCP server, so we will see the breakpoint getting hit. So I'll ask, what is the weather of New York? And enter. So here, first let me go through what has happened. So you can see here, it added the chat history, whatever I have typed in, and then it had the function behavior as auto, and here it figured out that it has to call this function get weather MCP. Weather is the name that I provided in the code, if you remember. Let me show you. This is the name. So that was the first one, and then dash get weather MCP, which is the name here, and then it is trying to call this function with the argument city as New York. So here city is coming as New York. So I'm just going to execute, and you can see this is running on the MCP server we have. So I'm going to just continue, go back, and if I continue, you can see that the server returned this response as city as New York, temperature is 22, and condition is sunny. And then finally, the assistant response is the weather in the New York is sunny with a temperature of 22 degrees centigrade. And it is guessing that the temperature type is centigrade, because I have not provided whether it's a centigrade or Fahrenheit. This is something I discussed in my last video also. We could add the type of the temperature. So this is a very simple example of how we can use an MCP server with semantic kernel agent. And as you can see, it is really, really easy to implement this. Very simple, easily understandable code, which we can use in .NET. The only thing, as I mentioned, this function, as you can see, this one is still in an evaluation process, so it might change. But I'm pretty sure if it changes, something else will replace it, which will allow us to do the exact same thing. Because at the end of the day, the goal is a client should be able to talk, an MCP client should be able to talk to an MCP server, provide the tool, let the MCP server execute the tool, return the response, and that response had to be fed into the AI through semantic kernel. So that is all I wanted to share for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and if you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.